Close your eyes and try to imagine a color you've never seen before. Not a darker shade of blue. Not a mix between purple and orange. A genuinely new color. Something that has never existed anywhere in your experience. You can't do it. And the reason why is one of the strangest things about being human. Because it's not a failure of creativity. It's not a failure of intelligence. It's a hard limit built into the architecture of your mind. A wall you can't see, can't feel, and can't climb over. And once you understand why it's there, you'll never look at the world the same way again. Let's start with the obvious question. What even is a color? Most people think color is a property of objects. The sky is blue, grass is green, blood is red. But that's not what's actually happening. Color doesn't exist out there in the world. It exists in here, inside your skull. What's actually out there is light. Electromagnetic radiation bouncing off surfaces at different wavelengths. Your eye catches that radiation, and your brain converts it into an experience, the experience we call color. Here's where it gets strange. Your eye doesn't detect all wavelengths equally. It uses 3 types of specialized cells called cone cells. One type responds most strongly to long wavelengths, what we call red. One responds to medium wavelengths, green. One responds to short wavelengths, blue. Every color you have ever seen in your entire life is just a combination of signals from those 3 types of cells. That's it, 3 inputs. That's the entire palette your brain has to work with. This is called trichromacy. And it means that when you try to imagine a new color, you're trying to imagine a 4th signal. A signal your brain has never received and has no hardware to process. It's like trying to hear a sound using only your eyes. The equipment isn't there. But here's what nobody tells you. The equipment being missing doesn't mean the color doesn't exist. In 1975, a marine biologist named Roy Caldwell was studying a creature called the mantis shrimp off the coast of Hawaii. The mantis shrimp is not a shrimp. It's not a mantis. It's a small crustacean that looks like someone designed it while extremely distracted. It punches with the force of a bullet. It can see in 16 different color channels. Where you have 3 types of cone cells, the mantis shrimp has 16. It detects wavelengths of light that your eye cannot register at all. Ultraviolet, infrared, polarized light. Colors that have no name in any human language because no human has ever seen them. When a mantis shrimp looks at a flower, it is having an experience that is completely inaccessible to you. Not just different. You cannot imagine what it sees. You cannot approximate it. You cannot get close because your brain has no raw material to build that experience from. And this is the part that should stop you cold. If the mantis shrimp could talk, and you asked it to describe what it sees, it couldn't. Not because it lacks the words. Because you lack the receiver, the experience would have nowhere to land. Now, here's where it gets philosophical. And I mean that in the most unsettling way possible. In 1982, a philosopher named Frank Jackson published a thought experiment that has been argued about ever since. He called it Mary's room. The setup is this. Mary is a scientist who has spent her entire life in a black and white room. She has never seen color, but she has read every book ever written about color. She knows the exact wavelengths of red light. She knows which cone cells fire when you look at a ripe tomato. She knows the neuroscience, the physics, the biology. She knows everything there is to know about color, scientifically. Then one day, Mary walks out of the room and sees a red apple for the first time. Jackson's question was this: does Mary learn something new? Most people's instinct is yes, obviously yes. She knew the facts, but she didn't know what red looks like. She didn't know the experience. And that gap between knowing everything about a thing and actually experiencing it is exactly the gap you're standing in front of when you try to imagine a new color. You can know that the mantis shrimp sees 16 channels, you can know the wavelengths, you can know the neuroscience, but you cannot know what it's like. Because knowing and experiencing are 2 completely different things, and your brain can only build experiences out of what it has already received. But here's where it gets even stranger, because some humans have gotten closer to crossing that line than others. In 1948, a Dutch scientist named H.L. de Vries was studying color blindness when he noticed something unexpected. Some women, not men, women, appeared to have a 4th type of cone cell, a mutation that gave them an extra receptor sensitive to wavelengths between red and green. He called them tetrachromats, 4 color seers. For decades, nobody knew if this extra cone cell actually did anything. Having the hardware doesn't mean the software is running. But in 2010, neuroscientists at Newcastle University named Gabrielle Jordan ran a study that changed the answer. She found a woman, referred to only as CDA29, who could reliably distinguish between colors that looked completely identical to every other person tested. Colors that were, by every standard measurement, the same. To CDA29, they were different. She was seeing something that wasn't there for anyone else in the room. There are an estimated 12% of women who carry this genetic mutation. Most of them probably don't know it. Most of them probably can't use it because the brain needs to be trained to interpret a new signal. But some of them, a small number, may be walking around right now seeing a version of the world that you will never access. Not a better version, not a worse version, a different one that has no name, one that you cannot imagine. And this brings us to the strangest part of this entire story. The colors your brain actively refuses to let you see. In the 1970s, a psychologist named Leo Hurvich was studying something called opponent process theory. The idea is that your brain doesn't just process colors independently, it processes them in pairs. Red versus green, blue versus yellow. The cells that fire for red are the same cells that are suppressed for green. They are opponents. They cannot fire at the same time. Which means, by the logic of your own visual system, there are colors that are physically impossible to perceive. A reddish green, a yellowish blue, colors that would require two opponent signals to fire simultaneously, which your brain simply will not allow. Except, in 1983, two researchers named Hewitt Crane and Thomas Piantanita found a way to force it. They used a technique called retinal stabilization, fixing an image directly onto the retina so the eye couldn't move away from it. And when they placed a red field directly adjacent to a green field with no border between them, something happened that their subjects struggled to describe. They reported seeing a color that had no name, a color that seemed to violate the rules. Some described it as a kind of visual static. Others said it was like seeing something that shouldn't exist. One subject said it looked like the color was simultaneously both and neither. These are called forbidden colors. Colors that exist at the edge of what your visual system will permit. Colors you can only see by tricking the machinery. And the fact that they exist at all tells you something important. The limits of your color experience are not the limits of color itself. They are the limits of the particular hardware you were born with. So here's where we've ended up. You cannot imagine a new color because imagination is reconstructed. Your brain takes things it has already experienced and recombines them. It cannot generate something from nothing. It cannot build an experience it has never received a signal for. This is not a flaw. It's how every mind works. It's how your mind keeps you sane, keeps your experiences coherent, keeps the world from dissolving into noise. But it means that the world you experience is not the world. It's a model, a very good model, built from 3 types of cone cells and decades of learned associations. And outside that model, there are colors that have no name in any language you speak. Colors that mantis shrimp see on Tuesday mornings. Colors that tetrachromats might be seeing right now while standing in line at a grocery store, unable to explain what they're looking at. Colors that your own visual system will produce if you trick it hard enough and then refuse to let you hold on to. The philosopher Thomas Nagel wrote a famous paper in 1974 called "What Is It Like to Be a Bat?" His argument was that there are facts about subjective experience that science cannot capture. That knowing everything about echolocation doesn't tell you what it feels like to navigate by sound in the dark. That there is something it is like to be a bat, and that something is permanently inaccessible to you. The same is true of color. There is something it is like to see a 16th color channel. There is something it is like to see reddish-green without the visual system shutting it down. There is something it is like to be CDA29, standing in a room full of people who all think they're seeing the same thing. You will never know what those things are like. Not because you haven't tried hard enough, because the experience requires hardware you don't have. And no amount of description, no amount of science, no amount of imagination can substitute for the signal itself. Here's the part that stays with me. We spend a lot of time assuming that our experience of the world is the experience of the world, that what we see is what's there, that what we can imagine is what's possible. But color, of all things, is the clearest proof that this isn't true. The visible spectrum is a tiny slice of the electromagnetic spectrum. The colors you can see are a tiny slice of the colors that exist. The colors you can imagine are a tiny slice of the colors you can see. And if that's true for something as basic as color, something you've been doing since you opened your eyes for the first time, what else is there? What other signals are bouncing off the walls of your experience that you have no receiver for? What other rooms are you locked out of? Not because the door is closed, but because you've never been told there's a door? You can't imagine a new color. But somewhere out there, Something can see one, and it has no idea you're missing it.